Hello, my name is Brady Spalding, and today I'll be giving a presentation over coatings for material anti-wear coatings. And so the title of the paper was Hard Coating Material Selection Using Multi-Criteria Decision Making. The authors and journals are listed there. The scope of this paper was basically to find the optimal anti-wear coating for mechanical components, really helping and also helping to construct a database for a baseline for engineers to use in engineering problem solving. The key questions addressed were obviously what is the optimal material coating of a list of preset materials, and how accurate is the analysis that the authors used to determine this. So basically in their methodology they use several models to determine what would be the optimal coating. They use what's called a Pareto optimal solution, a Topsis approach, and an Ashby approach. And all three of these are basically different ways of taking multiple materials and multiple parameters and finding out which material is most optimal, and then finding a way to rank these materials. And so they also use something called hierarchical clustering. That basically just means that it groups like materials with like attributes together, so you can find substitutes for one material for the other that would be close. And then a Pearson correlation coefficient, and that basically means that it determines how well the attributes correlate with one another, and that can be used for multiple different things. So the material performance index they used, the first one was hardness over Young's modulus, and the second was hardness cubed over Young's modulus squared. Those are both important for determining anti-wear properties. And then the materials and process they surveyed, they used 37 technically important materials, and then they used they evaluated those for hardness, Young's modulus, and coefficient of thermal expansion. Those three things really come into play when determining the anti-wear. So this is the chart of the results based mostly on the Topsis index, and we'll get into that when we talk about key result 1, which is which material is best. So from the chart you can see carbon was best, and that was followed by boron nitride, boron carbide, and silicon nitride. Those are all close options to close to optimal. Obviously magnesium oxide was the worst option, and then basically the takeaway from this is that this is the list of the ranking of materials. This would be the shows the best and the worst components for anti-wear. Key result number 2 was how accurate is the analysis. So the fact that the Topsis, Pareto optimal, and Ashby results all coincide with one another show that the analysis was fairly accurate. And then from beyond that, the hierarchical clustering shows gives a good idea for what materials substitute well for the optimal materials, if optimal materials are not possible given design constraints. And then high correlations between attributes show the data can be used to accurately predict results, and it also just reinforces the accuracy of the data in general. And then the important takeaway from this is that the data is accurate enough to be used in engineering in practice, at least as a baseline, and that the analytical approach is sound. The approach used by the authors, it's dependable. And so these graphs here basically show the approaches used. The top left is the Pareto optimal, the graphical representation to find the optimal solution. The top right there shows the Ashby chart, where they use log functions to with the intercepts to determine the most optimal and least optimal material. And then the bottom there is the clustering, the dendrogram that shows which materials would be good substitutes for one another. So in summary, the best materials for wear resistance were documented. The analytical approach was well thought out and explained. My personal critique would be that the paper is very useful, it's well written, but I would like to see a few more figures, such as a more detailed Ashby chart or multiple Ashby charts, um, and then also that the materials 5 through 36 weren't really discussed at all in the paper. I'd like to see just a little bit about a little bit of discussion about the middle ground there, and that's basically it.